Okay, welcome back. Today, as the title suggests, we're going to be looking at hacking the Windows OS. Granted, we're actually going to be working with much older versions of Windows, but this is only just to build up the basic principle idea of what you would need to do in order to compromise that particular operating system. So, just moving on to the next slide. There are actually two parts to this video, and the first part we're going to be looking at hacking a Windows operating system, namely Windows XP, using no firewall as a protection. So hopefully this will emphasize the importance of a firewall and the role that they play within your network security. The other reason for doing this is that you can actually develop malware to compromise most software firewalls. Much more difficult to do that against a hardware firewall, and again this will emphasize the role of that firewall. So the key to hacking is about learning various processes to achieve a goal. Many of the things that you will learn on your journey to become an ethical hacker, it's about rinse and repeat. You're constantly repeating similar processes and methods, but it's knowing what tools are in your palette or what colors are in your palette before you actually do your painting, which is effectively the pen test in itself. So when beginning in ethical hacking, it is common to learn processes that may be hindered in the real world by improvements to security. So it's very common that most beginners in ethical hacking will actually use tried and tested methods as opposed to more modern techniques in a bid to build a foundation that then you can effectively learn additional skills to actually beat the more modern security methods that have been introduced since that particular process was first conceived. So Windows has been patched so many times, and hackers develop techniques to beat the system as quick as holes are closed. However, to develop an understanding of the phases of ethical hacking and become familiar with the tools without the firewall is important. Then develop additional skills to bypass the security the victim will have in place. So you'll learn the basics, learn the processes, and then over time you'll start developing newer techniques to get around all the various security measures that have been added later on. So in the lab that we're going to use today, to build it, you will need obviously Kali Linux, up-to-date version, fully updated, and you'll also need Windows XP, whether it be 32 or 64-bit, and in order to make it as easy as possible for you to have success, then keeping those particular instances unpatched if possible. So what you will see on my version of Windows XP is I've actually turned the Windows Update off. I've taken off anything that could possibly hinder the process and disabled that, including the firewall. You'll also need to create a virtual connection, because you don't actually want this virtual machine to be accessible, or any of the virtual machines to be accessible from the internet. So it is important to use the host-only connection and create a private switch for this particular task or activity. And then we will actually look later on at compromising a Windows system which will disable the firewall, and in slide 7 or a bit later into the presentation I'll actually show you the difference, or when you can detect that a firewall is actually interfering with your progress or not. So you will actually see the differences and how you can detect that from the outside to see if somebody's actually using a firewall or not. So that's the basic idea of the lab itself. So the first compromise or vulnerability I'm going to exploit is something called EternalBlue. It was created or developed by the NSA. but then in a hacking group called the Shadow Brokers broke into NSA secure systems and actually made these tools public. 1 month after they were made public, Microsoft then closed the actual vulnerability. But there is a couple of Windows operating systems which are vulnerable, which is why we're using XP for this first method. We're also going to be using a tool which is embedded into Kali Linux, which is the Metasploit framework console. So we're going to use this tool to both scan the target, exploit a vulnerability, and where necessary we can even collect the data using this particular framework. So it is a very powerful tool, very commonly used tool that is available in Kali Linux and also Parrot OS. If you ever come across that, you can actually use Metasploit frameworks on these platforms. So we're going to move into the first attack. Again, this is going to be Kali Linux versus Windows XP, and we're going to be using the Metasploit framework in order to exploit this vulnerability. So first of all, just going to move over to the virtual machines. So here you can see that I've got a version of Kali Linux running, so I'm just going to log in to that. And while that's logging in, I'm going to switch over to a Windows XP virtual machine. As you can see here, the IP address for the virtual machine is 192.168.75.130, and if I switch over to the Kali machine and open up a terminal, first things first, make it slightly bigger. I'm going to do sudo su, enter my password, and we can check for the IP address, and you can see here that the IP address is 192.168.75.128, so it is in scope of the Windows XP machine. And what I'm doing here is just filtering it down. So I'm going to clear the screen. I'm going to bring up the ifconfig as it is here. I'm going to focus solely on ETH0, so Ethernet 0. So that's the only one I really want to focus on. And then by using grep or piping the result into grep, I'm going to now focus solely on the line that starts inet, so that I've got a clear image of the IP address right at the top of this console window. There we go. So now that's done, I'm going to split my terminal horizontally, so there'll be a separate terminal drawn out here, and I can then keep the IP address here in view as I move through the different screens. Next thing I'm going to do is MSF console. So I'm going to actually, before I even do that, actually the first thing I'm going to do is just test that I can actually access this Windows XP machine, which is the IP address is there. So I'm just going to I'm just going to ping that address just to make sure I can actually get it, and as you can see there, it's pinging, no problem. One of the ways to detect if somebody's using a firewall, if I just open up the firewall here, you can see that everything updates virus protection and firewall have been all disabled on this machine. However, if I was to enable the firewall, then come across back to the pinging, you will actually see that it will hang here for a considerable amount of time and we won't get a quick response. Effectively, the actual ping is failing against the Windows XP machine. So even though it's an old operating system, that was one of the features that Windows or Microsoft employed to actually try and stop people discovering machines that they're not supposed to. So I can again turn this off, and if I go back, you can see instantly it's starting to ping. So we can actually tell straight away if somebody's using a firewall. Now, even if they were using a firewall, I can actually use various methods to detect whether a host was up. I could actually use Nmap, and if I use Nmap with a stealth, I could potentially find this machine and actually discover whether that machine exists or not. So if I was to do something like if I was to do an Nmap again against 192.168.75.130, if I was to do an Nmap there, you can actually see that the ports, 997 ports are closed. The host is up, but this is because clearly the firewall is off. So if I now turn the firewall on and I did the same again, you can see that it comes back with a message. The host seems to be down. If it was really up by blocking the ping, no probes. So you can see that it's basically trying to fool Nmap or any other person looking that there's actually no host there, which we know there clearly is. You can see that there. So in that instance, if I wanted to really detect if there was a machine there, one of the things I could do is do a search of services in sort of stealth mode. Most preferred way would actually be PN, and that would just say no pinging. Because of the type of method I'm using, we need to be administrator, and then hopefully, even though the firewall is up on this machine, even though it's clearly on, by doing this configuration of Nmap, hopefully I should be able to detect whether or not a host is there. So it'll take a couple minutes to do it. There we go. And you can actually see now that a scan has been done. It's not showing 1,000, so there's a filter ports, didn't get any response. It's got the MAC address, but it's also, more importantly, telling me straight away that there is a host there and it is up, so it has detected. It took about 21 seconds to find it. So there are methods and techniques of being able to detect a system even if the firewall is on, but just to make the demonstration and understanding the process a lot easier, we're just going to disable this for the moment, and we're going to do the attack whilst the firewall is actually down. So I'm just going to clear again. So we know the host is there, the firewall's currently down. So what I want to do now is I want to scan that system and see if it's actually vulnerable to the EternalBlue exploit. So MSF console. So I'll type that into Kali. And this will start the Metasploit framework console. And there we go. So now that we're in Metasploit, and we can tell that it has given us the MSF and a version number, so this is Metasploit Framework 6. So now that I'm here, I want to find out if that XP machine here is actually vulnerable to EternalBlue exploit. So first thing I'm going to do is just type the word search, then Eternal, thinking that it may be EternalBlue, it may be Eternal Space Blue, but if I type the word Eternal, then it will basically list all the results with Eternal in their name, and there we go. So we end up with all the exploits there. I'm just going to move this up a bit, and there we go. So you can see we've got 5 exploits starting from 0 to 4 with the term EternalBlue. Now, depending on which operating system you're trying this against, you will need to try out or experiment with different versions. So for this particular one, I know the machine itself. If I go to the properties, pardon me, it's been a while since I've been in XP. So you can see here that it's Windows XP Professional 2002 version of the operating system, and it's been patched to Service Pack 3. So what I'm doing here is doing a system information, and by scrolling through this, again you can get the same details, but what I'm looking for is this here, which is the system type, and you can see that the system type is an x86 based PC. In other words, it's a 32-bit computer. If it was 64-bit, it would be x64, but we can see here that it's an x86, so we know it's a 32-bit machine, and that's how we would find that out. Okay, so I'm just going to clear this, not CLS on here. Again, I'll just pop up the IP address. There we go. So we know it's a 32-bit machine, so some versions of this will work better with the 64, some will work better with the 32-bit. So I've already tried and tested this out, so I'm actually going to scan first the system to see the vulnerability that it has. So I'm going to actually use 3. You could actually just copy and paste the whole of this line here, and instead of putting 3, I could decide to paste that in, and that would actually work. But you can also just type the number of the search result, and you can see there it now has told or set up Metasploit, giving us access to that particular type of scan. We can also see options, so if I do show options, it gives us the options of settings or configurations, how I can actually set up this exploit. The only thing really that I'm concerned about or needs to be set here is the rhost, which is actually the remote host. You can see here at the moment it's blank, so it doesn't know who the target is. So I'm going to just set our hosts, and then we want the target IP address, so we know already that this is a 192.168.75.130. Now yours may well be different, so do take note of the specifics of your particular setup and make the alterations as needed. So for my lab here, this is the IP address. You'd need to adjust it for your own. If I press enter now, you can can see that has worked. And if I go back to show options, you can see now that our host now has a target IP address here. So I can just clear this for the moment, and we're pretty much ready to go. So I can now type run or exploit, and hopefully that should scan the target machine with that IP address and actually tell me whether or not that machine's vulnerable to EternalBlue exploit. So give it a set, and there you go. Very quickly it has come back and it has stated that it is vulnerable to that particular attack, and it's also given me the version, type of Windows, the fact that it is a 32-bit, confirming. So that is success. Again, just to show you the difference with the firewall, if I was to do that again and try the same exploit again, just against the operating system with a firewall on it, give it a second. And there you go. And what we would see here, it scanned the host 100% complete. We basically verified that the host is there. However, when it came to checking the vulnerability, you can see here that it's actually timed out, and that's the firewall actually blocking that particular attack. So we now know without the firewall this machine is now vulnerable. So just to bring up the same results as before, I'm going to just type search but with no parameters at the end of it, and what this will then do is allow me to bring up the previous list of results from my last search. So there we go. So now that I know that it is vulnerable to this attack, we have here two types of attacks that we could perform. Now the first one I can tell you would be the one I'd used against a 64-bit machine. This one here, so this one exploit here, is the one I'd used against a 32-bit machine. So as I know this is a 32-bit operating system, I'm just going to use that. So I just type use. I could again have said use number 1. There we go. And this exploit that I'm using, MS17_010, this exploit that I'm actually doing will give us access to the machine, but in order to take control of it, I do need to deliver some form of payload. And because there was no payload being given for this particular exploit, it has defaulted to the most common payload, which is a Windows Meterpreter reversed TCP. So Windows is obviously the platform that this is targeted, this payload's targeted against. Meterpreter is a shell, so this is a remote shell that we can access and actually pass commands from our machine here on Kali, which will then be performed on the Windows XP machine. And the shell that is being created is done so using a reverse TCP method. So that's the default payload that is currently being set. However, what I want to do here is I want to, if I just go back to the presentation, so what I want to do here is, we've seen how this can be impacted by the different firewalls, whether it's enabled or disabled on the target. But what I want to do here is I want to open a shell, and again we've got two different systems that we could use, or different types we could use, but what I want to do here is I want to change the exact payload. So I want to alter the payload that's available here. So actually I'm not going to change the payload. So if I just do show options, I'm not actually going to change the payload here at all. I'm actually going to keep the default payload as it's set at the moment. And what I'm actually going to do is we've got, if I just scroll up, you've got our host is not set in this payload, so I'm actually going to set the payload here. Sorry, I'm going to set the our hosts here, which is 168.75 130. Yep. There we go, and then I'll clear and I'll show the options. And before I do, Kali is actually taking on the role of the listening host. So this particular Kali virtual machine is going to be our listener. In other words, this is going to be our command and control center. So the IP, as you can see here, is 192.168.75.128. So if I now go to show options, you can see that the L host and the L port, in other words the listener host and the listener port, have been configured, and that is the IP address of our Kali machine, and that's the port that I'm actually using for this particular attack. If I now scroll up after setting our host, you can see that our host address is set, and also the port is 445. So that's the targeting port that we're actually targeting, which I already know is open on the target machine. If you did a nmap and had actually looked at the ports that were listed, then 445 is one of those ports that are open at the moment. So I'm going to use that as my entry point for this attack. So now that I've configured everything here, and as I said, the payload, I'm just keeping it as the default for this particular one. I will change it in the next attack, but with this first attack we're just going to use the default payload. And once I'm happy everything has been set, I can now type run, press enter, and off it will go. And it starts to craft some malware, deliver that malware, start the services off running, deletes the malware, so it cleans up after itself once it's established a session. And we can see that if you go through the logs, that effectively some malware was created, given some random name, we got the service set up, and then once that service was set up and we've got that connection in place, you can now see that it deletes that original malware that it inserted on the target machine. So there is no trace on the target machine of anything happening, and as you can see here, other than the alert telling me that I should have some form of security in here and that I'm at risk, there isn't actually anything here to notify the user that there is anything actually going on in the background. But I now have access to that machine. So now that I have got access to that machine, so if I just swap back here, so now that I have got access to that machine, then I can now take full control over the computer. And as I said, you can't actually see that anything is going on as far as the user is concerned. They're still in control of the machine, but in the background I have now got a session started, and if I just scroll back up just so you can see what has happened here. So we've picked the type of exploit that's going to give us access. We've also set the R host of the XP machine. We've got the payload, which is, as I said, the default, and we've also got here the IP address of the Kali box, so you can see that just up here, and we're using port 444. So all of those settings were set up first, and once we've done that, we've then executed using the run statement. And then after that, you can see going through the logs, it's created some malware here. That has been successful, the service has been successful. It's then deleted the malware, so to remove any trace. And then at the end here, you can see I now have a Meterpreter prompt. So now that that is done and in place, let's talk a little bit about Meterpreter. So Meterpreter is a Metasploit attack payload that provides an interface, a shell to the attacker, for which to explore the target machine or execute code. Meterpreter is deployed using a in-memory DLL injection. As a result, Meterpreter resides entirely in memory and writes nothing to the hard disk, which is important, because then if there is any forensics or any analysis after the attack, then there is nothing there for a forensic team to find. It's very difficult for them to actually trace the point of origin with this type of system. So there are a number of different commands here. So there are 10 commands that I've listed here, but these are the most common commands. There are actually a lot more. So if I move back over to my virtual machines, and if I was to type help, you can actually see here a list is generated, and there are a number of different commands. So there are so many different commands, so many different things we could actually type in to that shell and have executed on our target machine. Okay, so one of the things that you may want to do very early on is system info. So if we wasn't in control of the workstation that we were attacking, we want to know exactly what that system is and as much information as possible. So we can type sysinfo, and that will tell us straight away that we've got 2 users logged in, which makes sense because we're the actual user, the person who's actually in control of that operating system, is logged in here, actually logged in, the administrator. However, we're also logged in using a backdoor access, so 2 users are currently logged on. The domain, the networking domain for the Windows box is just on the default work group. The language is set to US. The architecture is an x86. You can see the name of the computer and also the operating system and version that is currently being used. So we can get all of that information remotely. So what else would be useful? Let's have a look. If I do help again, you can do certain things such as interface, so you can do keyboard scans and capture keystrokes, so you can actually do key logging process using this. You can actually grab a screenshot of the target machine, so you can see what's going on the machine itself. If the target machine had a webcam, you can turn that on. You can also turn the mic and web camera on from here. So it's a very powerful tool. There are a lot of things that we can actually do here to actually take control. We can also, if I type the instruction shell, I am now on the command or terminal of the actual target machine itself. So let's see if I can prove that. So first of all, I go to C drive, dir. So there's my C drive, and if I just do it here, you can see I've just made a directory called temp, and I can access temp, and let's there we go, I made another directory within a directory, and if I switch straight over to my machine here, just move that out of the way for a minute, go to the start, my computer, onto the C drive, you can see that I've got a temp folder, and you can see that I am here. So I am definitely in control. I can put a text file here, and I can go straight back to the machine here, go into dir, and you can see that I have a text file here. So I am in complete control. I've got access to that particular machine, and then once I'm done with that particular shell, I can do exit, and that takes me back to Meterpreter. As I say, I can do if I do help, I can do a screenshot. So if I go, yeah, and it's just a screenshot. So, there we go. And there's a screenshot being created, and it's stored in the home Kali, and it's as a JPEG. So if I go into home and I was to grab that JPEG, then you can see I've captured what's going on the desktop of that Windows machine. So hopefully I've demonstrated enough for you to see that that actually does work. And if I do again an exit here, it takes me back into Metasploit. And the thing is this, I can actually set this up so that I could have multiple machines that I am monitoring. Now this is the sort of thing that an attacker would do. They would actually set up a listening station or a control and command center and allow multiple machines to connect and start various instances of Meterpreter on their side, and then they can go from machine to machine, and they could upload, download the data at will. So that completes the very first part of this. If I just switch back to the presentation, so as you can see, these are the most common tools that are here that you could use in Meterpreter. So the second part of this video is really going to be focused on how could we get a Meterpreter session created with the firewall in place. And for this I'm actually going to use a slightly more modern operating system than XP, and it's only slightly. We're going to be using Windows 7, so I know it says XP there, that's a bit of a typo, but I'm actually going to be using Windows 7, and actually Windows 7 Ultimate to be precise. And I'm actually going to leave the firewall in place but show you how I could set up a similar sort of an attack, however with the firewall in place, and actually show you how we can do that. So how are we going to attack a Windows 7 machine, a more modern machine than the XP, with the firewall in place? And we're going to do that with something called a reverse shell, similar to what we did previously, except with the previous example we were the attacker breaking into a target machine to create a reverse shell through the firewall itself, without the firewall being in place. But this time what we're going to do is we're going to, rather than go to the machine to create the shell, we're actually going to get the target machine to reach out to us through their firewall and actually connect to our machine itself. So as I said, I am going to be using a slightly more modern operating system. So we're actually going to be using Windows 7, and as you can see there, it's Windows 7 Ultimate. So I'm just going to log in, and you can see there it's a completely different machine. We have a different IP address, it's a 129, so it's still part of the same network. However, it's a different target IP address. Okay. So again, if I wanted to just confirm what this machine actually is, so if I type system information here, you can see it's Windows 7 Ultimate. There's the computer, the user's name, and just having a look here. You can see this too is a 32-bit instance of this operating system running on here, and generally I went for 32-bit solely for the size more than anything else, but this would easily work on a 64-bit just the same. If I bring up the firewall, which I think I've got here already, and you can see the actual firewall is all on, so they're all green, so they haven't been turned off, they're all on. So the next hack that I do is actually going to be done with the firewall still in place. So if I switch back to the presentation, and we're going to break this into 4 phases. So there's 4 phases to this particular attack. It does kind of mirror the previous one, but if you think the previous one was doing this sort of on a automatic and we were doing this from the outside breaking in, this attack is really a mixture of trying to get the system to compromise itself. But in order to do that, because we need effectively the system to reach out, we need to create some malware. So the first part is actually crafting some malware that we can then infect our target machine with that first. So once we've created the malware, the next thing is we need to get it to the target. So this could be done via a dodgy website giving a free app, or we could get them to open an attachment to an email. There are various means. We could even have it auto run off a USB. There's so many different ways we could actually get this malware distributed to the target machine. The third phase is we create up our listener, and then by creating our listener on our Kali machine, once the user or the automated process triggers that particular malware, it will force the system to reach out to our Kali instance, and then from there we can then set up our Meterpreter session and effectively take control of that computer. So that's the idea of those 4 phases. So we're going to start right at the beginning, and the first thing we're going to look at is creating the actual malware itself. So I'm going to switch back over to the virtual machines first of all, and we're going to start off with Kali Linux. I'm going to go into a root terminal, so just put in the IP. You could have done this through sudo but I've decided to do it this way with this one. Okay, and just to confirm the IP address, so you can see there it's 128, so that's fine. That's the Kali machine. So we're going to craft now our malware, and to do that we're going to still using Metasploit's framework, but instead of using the console we're going to use something called Venom. And Venom is very useful for creating malware based on the Metasploit framework. So this is what we're going to do. Now, as you can see in light grey on your screen, I've actually done this already, so I'm not going to waste time rewriting all of this, but what I am going to do is take you through each stage of it. So you can see the command there on screen. So if we just break these down, so I'm going to switch back to the presentation and start to break some of these down. So the very first thing is obviously making sure we've stated that we're using Venom, and then the next thing was -a, and with -a we are picking the actual architecture. Is it a 32-bit architecture or is it 64? So x86 is a 32-bit, x64 is obviously 64-bit. So for this instant we know the machine is 32-bit, so it's a x86. And then we have here -- platform, and we're telling it what platform we're attacking, whether it be Windows, Mac or Linux. So we could use a target attack against any of the platforms. So for this one we're targeting a Windows machine. -p is therefore the payload, and the payload we're going to use is again an exploit which is for Windows Meterpreter, which is our shell. However, rather than reverse TCP, we're using reverse HTTP. And the reason for doing this is that with the previous attack it was using port 444. It could have been actually any of the ports, and this could also be blocked by most firewalls. So unless you know specifically that port is particularly open for incoming traffic, then the chances are your firewall is going to block it. However, the one port that is open bidirectional is port 80, and therefore we can use port 80 to actually send and receive data. So reverse HTTP allows to compromise or use port 80, or port 8080 if you're in a corporate setting. So we have lhost, so we've got the IP address, and then of the listener, so this would be our Kali machine, so we put the Kali machine's IP address in here, and then the next one would have been lport, and that would be the port number. So this is the port number that we want to connect to on the Kali machine. So this isn't the port that's being used to effectively leave the target machine, but this is the port that we're going to be connecting to on our command and control system. We're crafting a malware or an exploit, so a payload. So -f tells us which format the malware should be in, and we're going to have it as an exe because it is targeting a Windows machine, so we want it as an executable. We also want to evade, where possible, antivirus or most antivirus software. So by encoding our malware, we stand some chance of disguising it and making it not discoverable by the AV. So by using -e, we can use an encoder. Again, it's going to be 32-bit, and then we use a system, an XOR system, or algorithm, should I say, to actually encode our payload. The next one is iterations, so we're going to set that, give that a value, and effectively it's how many times to run it through this algorithm to try and disguise it. So we're going to run it through 9 times. And then on the next one, which is X, -x, we're going to use a template. In other words, we're going to use a template of an app that is known to Windows already, and we're going to use that as a template to disguise our malware. So when Windows sees it, or somebody was to see this particular malware, they would actually think that it was this particular app, which is a VNC viewer, which is a very common web camera, security camera app that can be used on a Windows system. So it's something that's familiar to many people who are interested in that particular area, and it's a software that we can disguise our malware to look like. -o, so O is the output, so this is how the payload is going to be saved. And again, we are going to save this particular file as VNC viewer, and we're going to give it the suffix 2 exe. Now this could actually be called anything. We could call this Chrome, we could call this Chrome installer, we could call it whatever we want, but for the purpose of this particular demonstration, we're just going to leave it with VNC viewer 2. So those are the breakdowns of the parameters we're using, and there are variations to all of these, but this is the one to do this particular attack today. So as you can see now, if you just scan your eyes over, you can see that I've put in the host, the listening host address here, and the port number. We're not so much concerned with the target machine specifically, because effectively we're doing this the other way around. In other words, this is going to be placed on the target machine, and it's the target that's going to connect to us, where with the previous attack method, we knew who we were, but then we needed to actually reach out to the target machine. So we were doing it the other way around. So once I'm happy with all those settings, I can press enter on my line. Give it a few seconds and it will create the malware for me. There we go, and you can see that it's gone through and tried to encode it 9 times. So it's encoded the payload, its final size, how big it is, so it's very small, and what the file is being saved as. And if I just do ls, you can see I created a malware called Acrobat Reader Pro, but on this occasion this is the one that we're concerned with, which is viewer VNC viewer 2.exe. Now the objective is to move on to phase 2. So phase 2 is really about getting this particular malware from our listening machine or our command and control center onto the target machine. And what I'm actually going to do here is I'm going to create a small web server, and there's different ways of creating web servers within Linux. It does give you quite a few options of how to spin up a web server that you can effectively lure a target to infect them with your malware. So I'm going to use the PHP server for this particular demonstration. So this is what I'm going to do, is I'm going to create a PHP server, put in the host and port for the Linux machine. I'm going to go to the target machine, open up a web browser, and this could be a link that I'd sent or emailed to the target. I'm going to get them to type in this web address. Notice it's HTTP, not HTTPS. And then to the IP address and port of the server that I've created, and then get them to download this particular software. Now this could be a link where I'm promising them VNC as an application, a free application that they can download. Okay, and then that is how I'm going to get it onto the target machine. So if I go just over to the target machine, what I am going to do is, if I go to machine, yeah, it's trying to see if I could find where I've downloaded this before, just to delete that. Okay, as I say, it's I'm on the wrong machine. That would be more helpful if I was on the right computer. So onto downloads, so I'm just going to delete all of those. So nothing inherited. There we go, that's done. So now if I come back here again, there, I've got that done. So the next thing now is I want to create this server. So I'm just going to do PHP hyphen capital S, and then I'm going to put in the address of the machine, and also the port that I'm going to open to host this particular site. So I'm using port 8080 to host this particular site. I could choose port 80 if I wanted to, as long as it's not already being used. So rather than port 8080, I could just use port 80, and then that will create a web server for me, or a development web server for me, that I can now use this link on the target machine and actually get that machine to link and effectively download. I could also have created a much better looking site in order to trick the user into downloading it, but for the purpose of this demonstration, this is fine. So I'm going to just go to this machine here. So I'll just move that over here a bit. I'm going to open up Firefox, and this will work with any browser. I'm not going to pick on Firefox specifically. So HTTP 192.168. Second. Right, okay. I'll try that again. HTTP colon /192.168.75.128 or 80. In fact, generally I might get away with not having to put the port there because that's default HTTP. The name of the file that I want to download, so vncviewer2.exe, and hopefully that should start the download. And there we go. So you can see that's downloaded up here. Right, I just realised swap the view over. There we go. So you can see here I'll put the IP address in, so I'll just do that again. If I just delete that file. So again, I'm just going to do HTTP ://192.168.75.128, and I'm not using 444. I'm going to just do / there, vncviewer2.exe, and now you should see that it's downloaded. And we've now got the file here. So that's the file that we, the malware now running, now on the target machine, which is our Windows 7 computer. So now that that's in place, we're going to move on to phase 3. And phase 3 is where we're going to open up MSF console, and we're going to get it to be a listener. So we're going to be listening out for anybody or any connections trying to reach this particular Kali command and control, and effectively then we'll be able to exploit that machine, even though that machine has got a firewall in place. Okay. So again, I'm going to switch back to the VM, and you can see that the firewall is still in place. We've got the malware on the target machine. We know what the address of that machine is, which is 129, and I'm just going to close the browser now, we don't need that. So from here, we're just going to move on to the Kali machine. We don't need the server running anymore, so we can close that. That server's gone. And we're just going to go to MSF console. Give that a second to start up. And now that's up and running, we can move on to the type of exploit we're going to be using. So we're going to use an exploit, and it's going to be a multi-handler exploit. So it can handle different types of exploits trying to connect to this particular machine. This time I am going to change the payload, so I'm going to set payload, and the payload that we're actually going to use for this is the Windows Meterpreter and we're going to use the reverse HTTP payload for this one, and that's been set. Just clear this and we'll show the options, and we're now going to set the L host, and the L host is the listening host. So again, we're going to set it to this current machine, this Kali machine. Sometimes it does work if you just do ETH0. Sometimes it will work out the IP address from that alone, so you just put in the name of the adapter. But I have had instances where it doesn't pick it up, that the IP address, and it just actually just says ETH0 and not the actual IP address. So you can see there that it's actually worked this time. So do options again. And as I say, there's no need for us to insert the target address in this, because all this is going to do, this exploit is going to do, is just going to sit and wait for somebody or some malware to reach out and connect to it. So we don't need to know who the target is, just the fact that this particular system is waiting to receive a connection. Now, when we crafted the particular malware, we did set the port for that. So I just need to check the port. So if I do MSF Venom again, so we did set the port to 444, so 4 4s. So all I need to do here is set the listening port to the correct port. You will have probably noticed that the default port here is 8080, which would probably be the preferred, because most firewalls will not see port 8080 as threatening, where port 4444 it wouldn't know, there's nothing default connected to that, so that would generally be blocked by most systems. So if you do have a problem connecting, then using the default 8080 as a corporate HTTP, that probably is the better port to use. But as the malware will be actually reaching out for this specific port, then it's important that they match. So again, I've set that there. And if I show options again, just to show that everything is now in place. We've got the listening port, we've got the ports number set, we've got the payload in place, and that's all we need to do. So now this is ready to go. So we can now just type run. That now puts the Kali box into a listening mode. So if I was to go back here, and really what we're looking for now is to trick the user into running this. So if I double click this, you can see it opens. Does give a security warning, but this isn't uncommon for many applications, so we'll run it. And if I now go back, you can see now that I've got a Meterpreter session running on this machine, and the firewall is still operational. So this is actually been done with the firewall in place, and I can still do all the things I could before. So there you go. So you can see there the name of the machine, the operating system, the fact that it is a 32 architecture, work group, the fact 2 users are on, etc. We can do screenshots. I'll put a dot there. So let's see what that does. So that then actually stores the screenshot in the root folder. Let's see if I can get this to go to home Kali. No, it's just going to store it in the root, which is fine. So let's just open up a folder here, and I'll go through the file system to the root, and then I'll need to open this as root. So I'll put a password in. Here we are, and you can see I've got 2 screenshots here. So let's open up one. There's one here, and let's open this one. There you go. So you can see that that has taken screenshots. Okay, so that hack has worked perfectly. Okay, so if I go back to the presentation, so we have now completed that. So once the listener has been activated, the next step is to wait, which we've done, and the target got the user to actually trigger the malware, so they were able to start the connection. To the user, nothing worked, so they didn't see anything. The typical thing for many users may well be to delete this, and if they do delete this or try to delete it, you can see that it won't allow them to do that. And this is because if I was to go to the task manager, let's sort this into alphabetical order, you can see that this process is running. Now a more knowledgeable user would pick up that this is potentially malware and would then seek to end this process, and then once that process is ended, they could then delete that. And if we now go back to our Kali machine, now that the process has been deleted, let's try sysinfo again, and you can see that it's starting to hang, giving us our first indication that the user has actually got rid of that malware and effectively stopped that process from working. Now there is ways around this. I won't show that here today. However, you have hopefully picked up or learned something about how reverse shells can be used to actually compromise a system, even if it has got a firewall. Okay. Again, I've done that schoolboy error. If I just change the screen there. So if I show you here, there was the VNC which we've now deleted, but it wouldn't allow us to delete, so by opening up the task manager I was able to find it here. So if I just go back a step, just so you can see how this works. Go back a step just so you can see how this works. So I'm just going to http mi2 vnc viewer 2.exe. Go here, change that to 1980. And it's not HTTPS, it's HTTP. Let's try that again. There we go. That's there. Let's go back to here. Let's run that. On this machine, let's close this browser down. Run it here. Back to our Kali machine, we've got our Meterpreter session. So if I just click here, sys info, give it a second, there we go. So we know we're in control, or potentially, of that machine. So if I now go back here and I try to delete the malware, you can see that it says okay, it's going to put it in the recycle bin. Click, and now you can see it's not allowing us to delete it because it's still effectively running, even though the user can't see anything happening here. So if I was to access the task manager, I'll sort this into alphabetical order, and I'm looking for VNC, so it should be somewhere here. And you can see VNC viewer 2, and it's actually running. So I can now end that process. Now I can delete this file. And if I now go back to the Kali machine and then try sysinfo again, and you can see it's hanging, and now it's come up with an error running command system info, and basically it's timed out, and that is because the connection has been lost on this end. Now there is a way to ensure that they can't kill the process, but I won't be showing that here today. So hopefully you've picked up something from that. So if I just go on, we have been able to successfully break into a machine, even though the firewall has been in place, and be able to take control. So hopefully you've picked something up from that, and I will see you in the next one.